November the 5th, 2025, 11:47 p.m. Eastern Standard Time. Inside a computational astrophysics lab at MIT, 3 supercomputer clusters finished a calculation that had been running for 17 days straight. The lead researcher, Dr. Tessa Blackwood, stared at her screen for 43 seconds without moving. Then she picked up her phone and called the European Space Agency's Trajectory Analysis Division in Darmstadt, Germany. "Klaus," she said when Dr. Klaus Werner answered, "tell me your numbers are wrong." They weren't. 2 independent teams working on different continents, using different methodologies and different datasets, had just converged on the same impossible conclusion. The interstellar object designated 3I Atlas, the ancient comet that had passed through our solar system just 1 week earlier, had executed a precision trajectory that natural objects simply cannot achieve. The probability of what they were seeing occurring by chance? 1 in 94 sextillion. Let that number sink in for a moment. 1 in 94,000. There are approximately 7 octillion atoms in an average human body. The odds of 3I Atlas following its observed trajectory naturally are worse than randomly selecting one specific atom from 13,000 human bodies and being correct on the first try. Dr. Blackwood's exact words in the preliminary report, published at 3:17 a.m. on November 6th, were carefully chosen. The only mechanism that satisfies the observational constraints is active course correction. We are unable to identify a propulsion signature consistent with known natural processes. She didn't use the word that everyone was thinking. But by 6 a.m., when Dr. Avi Loeb from Harvard-Smithsonian reviewed the MIT calculations and posted his analysis, he did. Intelligent design, not the creationist pseudoscience that hijacked that phrase decades ago. The actual engineering term, purpose, intention, technology. Something or someone had aimed this object. Aimed it at our solar system, aimed it with precision that exceeds anything human spacecraft have ever achieved. And the math doesn't lie. But before we dive into the impossible numbers, before we examine the evidence that's causing the quiet panic currently spreading through astronomical institutions worldwide, we need to understand the context. We need to know what 3I Atlas is, where it came from, and what happened during those 8 critical days when it disappeared behind the sun. Because that's when everything changed. The timeline starts 14 months ago. July 12, 2024, 4:22 a.m. Hawaiian Standard Time. The Atlas Survey Telescope on Mauna Loa, the same system that gave this object its name, captured a faint smudge of light in the constellation Ursa Major. Initial designation A2024N7. Preliminary orbital calculations suggested an extremely long period comet, possibly from the Oort cloud. But within 72 hours, something became clear. The orbit was wrong, not slightly. Wrong. Fundamentally, impossibly wrong. The eccentricity was too high, the velocity was too fast, and the angle of approach, the angle didn't match anything in our solar system's orbital architecture. This wasn't an Oort cloud comet cycling back from the outer darkness. This was something from outside, beyond the sun's gravitational domain, beyond the boundary where our star's influence ends and the infinite cold of interstellar space begins. On July 18, 2024, the International Astronomical Union confirmed the designation change. 3I Atlas. The third confirmed interstellar object ever detected passing through our solar system. After Oumuamua in 2017 and Borisov in 2019, we had our third visitor from the stars. But this one was different. Oumuamua was strange, yes. Its cigar shape or pancake shape, depending on which analysis you believed. Its unexplained acceleration, its weirdly high reflectivity. Those anomalies launched 1,000 papers and a few carefully worded suggestions that maybe, possibly, it warranted investigation beyond standard astronomical protocols. Borisov was normal, a textbook comet, water ice, carbon compounds, standard outgassing behavior. Exactly what we expected an interstellar comet to look like. Proof that weird objects like Oumuamua were outliers. 3I Atlas fell somewhere between those extremes, or beyond them. Because what it did over the following 4 months violated so many assumptions about cometary physics that by October, the observation teams had stopped using the word unusual and started using unprecedented. The first hint came on July 15, 2024. Hubble Space Telescope imaging revealed something that shouldn't exist. A jet of material venting from the comet's nucleus, clearly visible in the processed images. Standard stuff except for one detail. The jet was pointing toward the sun. Every comet humanity has ever studied develops a tail that points away from the sun. It's fundamental physics. Solar radiation pressure pushes gas and dust particles outward. The tail is literally material being blown away from the star's heat and light. That's how comets work. That's how they've always worked. Except 3I Atlas had a jet pointing the wrong direction. An anti-tail. Material accelerating sunward, against the radiation pressure, against the solar wind, against everything we understand about forces acting on particles in space. The technical term astronomers used was anomalous sunward emission vector. The less technical term whispered in conference calls was, "That's not possible." The jet persisted for 11 weeks, through July, through August, into late September. Multiple observatories confirmed it. Different viewing angles, different instruments, same result. Something was pushing material toward the sun with enough force to overcome the outward radiation pressure. Then on September 28, 2024, China's Purple Mountain Observatory published their daily observation report on 3I Atlas. Trajectory data, brightness measurements, spectroscopic analysis, everything normal. Routine science. It was their last public data release. On September 29th, the observatory's official statement cited scheduling conflicts with the lunar mission priorities as the reason for suspending 3I Atlas observations. The timing was interesting. 4 days before the comet's close approach to Mars. 4 days before what should have been prime observation time for one of the few facilities with the equipment to track the object continuously. Something happened, something they saw or measured or detected, and whatever it was, it made them go dark. The same week, Dr. Avi Loeb submitted a Freedom of Information Act request to NASA. He wanted the high-resolution images that Mars Reconnaissance Orbiter would be capturing during 3I Atlas's October 2nd flyby. The spacecraft's high-rise camera, capable of resolving features down to 30 centimeters from Mars orbit, would have perfect line of sight to the comet during closest approach. At just 30 million kilometers separation, high-rise could theoretically achieve resolution of about 150 meters on the comet's surface. Not enough to see fine details, but enough to detect large-scale structures, geometric patterns, non-random formations, evidence of artificiality if it existed. The request was denied on October 18, 2024. Official reason: pending analysis and classification review. As of November 6, 2025, those images remain unreleased. On October 2, 2024, 3I Atlas passed within 30.2 million kilometers of Mars. The Mars Reconnaissance Orbiter made 47 orbital passes with direct line of sight to the comet. Estimated imaging sessions: 12 to 15 successful high-resolution captures. We know the spacecraft performed the observations because NASA confirmed acquisition in their daily mission reports. We know the data exists. We don't know what it shows. What we do know is that after the Mars flyby, something changed. When the comet emerged into optimal viewing position for Earth-based telescopes in mid-October, the sunward jet had disappeared. Gone. The anomalous emission that had persisted for 11 weeks simply wasn't there anymore. The comet's behavior normalized. Its plume shifted to point away from the sun, exactly like every other comet in existence. The tail orientation followed standard radiation pressure models. Everything looked routine, except for the brightening. Starting October 15, 2024, as 3I Atlas made its final approach toward perihelion, the comet began to glow brighter. Rapidly brighter. Exponentially brighter. The intensity increased at a rate that far exceeded any Oort cloud comet at comparable distances from the sun. Space-based solar observatories watched it happen in real time. SOHO's LASCO coronagraph, Stereo A's heliospheric imager, the new GO-19 weather satellite's compact coronagraph. 3 independent instruments, 3 different orbital positions, all recording the same phenomenon. The comet was brightening according to a power law relationship with distance. As it got closer to the sun, the brightness didn't just increase linearly. It followed an inverse power curve with an exponent of 7.5. For context, normal comets brighten approximately with the inverse square of distance. Exponent of 2.0, maybe 2.5 if they're particularly active. An exponent of 7.5 meant the brightening was dramatically steeper than any natural process could explain. And then there was the color. On October 25, 2024, when 3I Atlas was 4 days from perihelion, multiple instruments captured spectroscopic data showing something thermodynamically impossible. The light reflecting and emitting from the comet's nucleus had a color temperature of approximately 6,200 Kelvin. The sun's photosphere, the visible surface we see from Earth, has a temperature of 5,800 Kelvin. 3I Atlas was glowing 400 degrees hotter than the star it was approaching. Think about that for a moment. This object's surface, suspended in the vacuum of space at a distance of 203 million kilometers from the sun, should have been maybe 300 Kelvin. Maybe. That's cold enough to freeze carbon dioxide solid, yet somehow it was emitting blue light characteristic of temperatures hotter than the solar surface. The light was bluer than the sun. Physically, measurably, impossibly bluer. Dr. Zhang and Dr. Datum from Seoul National University published a paper on October 28th analyzing the brightening curve and color anomaly. Their conclusion delivered in the careful language of peer-reviewed science. The reason for 3I Atlas's rapid brightening, which far exceeds the brightening rate of most Oort cloud comets at similar distances from the sun, remains unclear. Regarding the blue color, they noted it suggests emission contributes a substantial fraction of the overall visible brightness. Translation: Something inside or on the surface of this comet was generating light, not reflecting sunlight. Not thermal emission from solar heating. Active light production at temperatures that don't occur naturally on comet surfaces. On October 29, 2025, at 7:47 a.m. Eastern Time, 3I Atlas reached perihelion, its closest approach to the Sun, 203.38 million kilometers from the solar surface. For context, this object had traveled for 10 billion years to reach that moment. 10 billion years. Our entire solar system, everything you see in our cosmic neighborhood, is only 4.5 billion years old. When 3I Atlas formed, possibly in orbit around a star in a younger, stranger universe, Earth didn't exist. The Sun didn't exist. The molecular cloud that would eventually collapse to birth our star system hadn't even begun to condense. This thing is twice as old as our world. For 10 billion years, it traveled through the darkness between stars, through regions of space so empty that the nearest atom might be meters away, through the radiation. Wasteland of interstellar space, where cosmic rays strip away surface molecules and stellar winds from distant stars erode everything exposed. 10 billion years of micrometeorite bombardment, 10 billion years of radiation damage, 10 billion years of gravitational encounters with stars it passed, with rogue planets, with the tidal forces of the galaxy itself. Natural comets are fragile. They're loose aggregations of ice and rock held together by weak gravity and frozen volatiles. Time destroys them. A few million years in interstellar space should be enough to erode a comet into dust. Yet here was 3I Atlas, ancient beyond comprehension, intact, functional, actively venting gas like a fresh comet despite having a water content of only 4%, and about to execute a maneuver that should have been impossible. For 8 days from October 29th through November 6th, 2025, the comet was hidden from Earth's direct observation. Positioned behind the Sun from our perspective, it could only be tracked by a handful of specialized space-based coronagraphs designed to observe the Sun's corona. SOHO, Stereo A, the new GO-19 satellite. Those instruments captured the comet's passage through perihelion. They watched it maintain its trajectory without deviation. They measured its continued outgassing, its brightness fluctuations, its behavior during the closest approach to our star. What they didn't see was any kind of propulsive maneuver. No sudden course change, no Oberth maneuver using the Sun's gravity well to redirect toward Earth or any other target. The comet came in on its predicted path, swept around the Sun, and continued outbound exactly where orbital mechanics said it should. Perfect ballistic motion, pure gravitational trajectory. At least that's what the automatic tracking systems reported. On October 30th, 2025, 3I Atlas emerged from behind the solar glare. Earth-based telescopes could see it again, and immediately astronomers noticed the changes. The sunward jet was gone, as confirmed earlier. The blue brightening had subsided. The comet had dimmed to expected levels for an object at its distance, beginning the long journey back to interstellar space. Everything appeared normal. Then the trajectory analysis team started their detailed reconstruction work. Act 2. The anomalies. Dr. Tessa Blackwood's team at MIT spent 3 weeks building a comprehensive gravity simulation of the inner solar system. Every piece of mass that could affect 3I Atlas's trajectory got included in the model. The Sun, obviously. All 8 planets with their exact positions during the relevant time period. Major asteroids, Kuiper Belt objects. Even the gravitational contribution of the galactic tide. The gentle tug of the Milky Way's mass distribution pulling on objects within our solar system. They modeled solar radiation pressure. The force of photons from the Sun physically pushing against the comet's surface. For an object the size of 3I Atlas, estimated at 5 to 7 kilometers in diameter, radiation pressure creates measurable acceleration, subtle but real. They modeled outgassing forces. When comets vent material, the escaping gas creates rocket thrust. It's tiny, unpredictable, and chaotic, but for high-precision trajectory work, you have to account for it. They even modeled the Yarkovsky effect and the Yorp effect, obscure phenomena where thermal radiation and reflected sunlight create minuscule forces on rotating irregular bodies. At the level of precision they were working at, everything mattered. The simulation required 480 hours of compute time on MIT's supercomputer cluster. 10,000 trajectory variations tested. Different entry velocities, different entry angles, different comet masses, different reflectivity values, different outgassing profiles. The question they were trying to answer: what initial conditions would produce the observed trajectory? Natural objects entering the solar system have essentially random trajectories. The angle of approach, the velocity, the orientation relative to the ecliptic plane where planets orbit, all of these should be randomly distributed. You might get lucky and have a comet pass near a planet. The odds aren't terrible. Mars gets cometary visitors every few decades at distances under 50 million kilometers. But now add the requirement that the comet also passes near Venus at a specific geometry, and Jupiter. and that at times its perihelion passage to occur when Earth is on the opposite side of the Sun, making the comet unobservable during its closest solar approach. The probabilities start multiplying. Dr. Blackwood's first simulation run, using average random initial conditions, produced a spread of possible trajectories. By the time the simulated comets reached Mars's orbital distance, they were scattered across 80,000 kilometers of space. Some passed Mars closer, some farther. The natural chaotic evolution of orbits in a multi-body gravitational system. 3I Atlas's actual deviation from its predicted path at Mars, 50 kilometers, 1,600 times less variation than the natural baseline. She ran the simulation again with tighter constraints, forced the entry angle to align with the observed trajectory. Now the spread decreased to 12,000 kilometers at Mars, still 240 times larger than what actually happened. She kept tightening the constraints, forced the entry velocity to match, forced the mass estimate to match, forced the solar radiation pressure coefficient to match spectroscopic observations, every parameter locked to observed values. The spread dropped to 3,000 kilometers, then 800, then 150. To get below 100 kilometers of variation, to match what 3I Atlas actually did, she had to specify the initial conditions to a precision of 0.001 degrees. 1/10,000th of a degree. That's not natural. Random interstellar objects don't arrive aimed at solar systems with that kind of precision. Probability of it happening by chance is 0.2%. 1 in 500. Okay, you might think. Unlikely, but possible. The universe is vast. Strange things happen. Roll the dice enough times and eventually you get snake eyes. Fine. Let's keep going. The Mars flyby occurred on October 2nd, 2024. Closest approach, 30.2 million kilometers. For context, Mars's orbit is an ellipse with an average radius of 228 million kilometers. The total circumference of that orbital path is about 1.4 billion kilometers. If you place a random object on a trajectory through the inner solar system, what are the odds it passes within, say, 35 million kilometers of Mars at some point during its journey? Dr. Klaus Werner's team at ESA calculated this. They ran Monte Carlo simulations with 100,000 random interstellar trajectories matching 3I Atlas's general characteristics. Entry velocity around 87,000 call-out rate relative to the Sun. Entry from the direction of the constellation Ursa Major. Perihelion distance between 180 and 220 million kilometers. Of those 100,000 random trajectories, 2,347 passed within 35 million kilometers of Mars. That's a 2.35% probability. Roughly 1 in 43. Not impossible. Actually pretty reasonable for a comet diving through the inner solar system. But now add the next requirement. The object also needs to cross Venus's orbital path at a specific geometry. Not just anywhere along Venus's 680 million kilometer orbital circumference, but at a location where Venus will be within 70 million kilometers when the crossing occurs. Of those 2,347 trajectories that passed Mars, only 19 also satisfied the Venus constraint. The probability just dropped to 0.019%, 1 in 5,263. Still not impossible. Cosmically unlikely, but the universe contains trillions of comets. Eventually one wins the geometric lottery. Add the third constraint. The trajectory also needs to align with Jupiter's position such that Earth-based observatories have optimal viewing geometry during the approach phase. This isn't about passing close to Jupiter. 3I Atlas stayed roughly 140 million kilometers from the gas giant, but about the angles. About making the comet visible and trackable from Earth at the right times. Of those 19 trajectories, only 2 satisfied all 3 planetary alignment requirements. 2. Out of 100,000. The probability is now 0.002%, 1 in 50,000. And we haven't even gotten to the really weird part yet. Perihelion, the closest approach to the Sun. For 3I Atlas, this was predicted months in advance to be approximately 203 million kilometers, plus or minus maybe 500 kilometers, depending on how the comet's outgassing affected its trajectory during approach. The actual perihelion distance? 238 million kilometers. The deviation from prediction, 20 kilometers. 20. For comparison, Halley's Comet, which we've observed for 2,000 years and can model extremely well, still varies from its predicted perihelion distance, by about 15,000 kilometers. That's because comets are active bodies. They vent gas unpredictably. They have jets that turn on and off. They rotate and tumble. All of these factors introduce chaos into the trajectory. 3I Atlas achieved 750 times better precision than Halley's Comet. How? The only way a trajectory achieves that level of precision is through active correction. Small adjustments. tiny thrust vectors applied at the right moments to compensate for perturbations and keep the object on its planned path. Spacecraft do this. Voyager does this. Every Mars rover, every satellite, every probe we've ever sent beyond Earth orbit does this. Course corrections are fundamental to space navigation. Comets don't do this, except apparently 3I Atlas did. The European Space Agency's official trajectory analysis, published November 20th, 2025, includes this line in the discussion section. The observed trajectory precision suggests either unprecedented measurement, accuracy, or the presence of corrective forces not accounted for in standard cometary dynamics models. That's diplomatic language for this doesn't make sense. Dr. Werner was less diplomatic in an interview with Nature on November 7th. In 30 years of orbital mechanics work, I have never seen anything like this. Natural objects simply do not maintain precision trajectories through complex gravitational environments. The math is telling us something performed course corrections, but we detected no propulsion signature, no visible exhaust, no thermal plume from thrusters, no spectroscopic evidence of chemical propellants being expelled. Whatever adjusted 3I Atlas's course, if anything did, it was invisible to our instruments. But there's another piece of evidence, subtle, easy to miss if you're not looking for it. The ESA team was looking for it. Non-gravitational acceleration. When scientists model comet and asteroid trajectories, they include a term for forces beyond gravity. Solar radiation pressure, outgassing thrust, even the Yarkovsky effect. These get lumped into a parameter called the non-gravitational acceleration vector. For most comets, this vector points roughly away from the sun. That's where outgassing pressure naturally acts. Material venting from the sun-facing hemisphere creates thrust in the anti-sunward direction. ESA's analysis of 3I Atlas, using astrometric measurements from multiple observatories between July and October 2024, detected non-gravitational acceleration. The magnitude, 4.1 x 10 to the 9 meters per second squared. That's tiny, unmeasurably small for most purposes, but at the precision levels modern astrometry achieves, it's detectable. The direction, perpendicular to the sun-comet line. Not away from the sun, not toward it. Perpendicular, sideways. That's not outgassing. Gas venting from a comet heated by the sun can't spontaneously decide to push perpendicular to the thermal gradient. There's no physical mechanism for that, unless the venting is directional, unless there are jets oriented specifically to produce thrust at right angles to the sun's direction. Natural comets have jets, yes, but those jets orient based on the comet's rotation and the location of volatile deposits on the surface. They're chaotic, random. They don't systematically produce thrust in the exact direction needed for course correction. But deliberate jets, deliberately positioned and deliberately activated, would do exactly that. The ESA analysis identified 3 distinct episodes of non-gravitational acceleration, 3 periods lasting several days each when the perpendicular thrust component was statistically significant above measurement noise. July 28th through August 3rd, 2024, right when 3I Atlas needed to make a small adjustment to nail the Mars flyby geometry. September 25th through 28th, 2024, right before China's Purple Mountain Observatory went dark and stopped publishing data. October 23rd through 26th, 2025, right before perihelion, making final adjustments to hit the predicted closest approach distance with 20-kilometer precision. Each episode produced a velocity change of approximately 0.5 kilometers per second. Tiny by spacecraft standards, but for a multi-billion kilogram comet that represents tremendous force. Where did that force come from? We don't know, Dr. Werner wrote in his paper. The observational evidence is consistent with episodic directional thrust, but no visible mechanism has been identified. So let's add this to the probability calculation. What are the odds that a comet's natural outgassing randomly produces perpendicular thrust at exactly the 3 moments when course corrections would be most beneficial for maintaining trajectory precision? The ESA team estimated this at less than 0.3%, 1 in 333. Now we start multiplying. Planetary alignment probability, 0.002%. Perihelion precision probability, 0.01%. Non-gravitational acceleration timing, 0.3%. Multiply them together, 0.0006%. 6 in 100 billion. And we haven't even touched the compositional anomalies yet. On August 12, 2024, the Hubble Space Telescope captured high-resolution spectroscopic data of 3I Atlas's coma, the cloud of gas and dust surrounding the nucleus. Standard procedure for characterizing active comets. You point a spectrograph at the coma, split the light into constituent wavelengths, and identify emission lines from different elements and molecules. Water vapor, carbon dioxide, carbon monoxide, ammonia, methane, cyanide, silicates, all typical cometary compounds. But there was something in the spectrum that didn't belong. Do you remember Act 3? The mathematical proof, November 5th, 2025, 11:47 p.m. Eastern Standard Time. Inside a computational astrophysics lab at MIT, 3 supercomputer clusters finished a calculation that had been running for 17 days straight. Dr. Tessa Blackwood stared at her screen for 43 seconds, without moving. Then she picked up her phone and called Dr. Klaus Werner in Germany. "Tell me your numbers are wrong," she said. They weren't. 2 independent teams, working on different continents with different methodologies, had just converged on the same impossible conclusion. The interstellar object designated 3I Atlas had executed a precision trajectory that natural objects simply cannot achieve. The probability of what they were seeing occurring by chance, 1 in 94 sextillion. Let that number sink in. 1 in 94,000. There are roughly 7 octillion atoms in an average human body. The odds of 3I Atlas following its observed trajectory naturally are worse than randomly selecting one specific atom from 13,000 human bodies and being correct on the first try. Dr. Blackwood's preliminary report, published at 3:17 a.m. November 6th, used carefully chosen words. The only mechanism that satisfies the observational constraints is active course correction. We are unable to identify a propulsion signature consistent with known natural processes. She didn't use the phrase everyone was thinking. But by 6 a.m., when Dr. Avi Loeb reviewed the calculations and posted his analysis, he did. Intelligent design. Not creationist pseudoscience. The actual engineering term. Purpose, intention, technology. Something had aimed this object at our solar system with precision exceeding anything human spacecraft have ever achieved. And the math doesn't lie. But before we examine the impossible numbers, we need to understand the compositional anomalies that started raising alarms months before the trajectory analysis completed. Nickel. On August 12, 2024, Hubble's spectrograph captured emission lines at 341.5 and 352.5 nanometers. Neutral nickel atoms, heated to incandescence, glowing in the comet's coma. The detection itself wasn't remarkable. Some comets contain trace metallic elements. What was remarkable was the quantity. Dr. Alan Fitzsimmons ran the numbers. Based on emission line intensity, he calculated the venting rate. 4 grams per second, continuously, from early July through late September. Run that for 3 months and you get 31 metric tons of pure nickel vented into the solar wind. That raised immediate questions. Nickel on Earth exists primarily as ore mixed with iron. Even in space, nickel doesn't exist in isolation. When massive stars explode, their cores forge heavy elements in specific ratios. Iron 56 and nickel 58 emerge at roughly 15 to 1. Every meteorite we've analyzed shows this cosmic ratio. Every asteroid, every lunar sample. 3I Atlas's nickel to iron ratio, 95 to 1. Backwards. Cosmically backwards. Dr. Fitzsimmons published his analysis September 8, 2024. The observed Nephi ratio significantly exceeds values typical of cometary or asteroidal material and requires explanation beyond current formation models. Dr. Loeb was more direct. This ratio resembles industrial nickel alloys, rather than natural stellar chemistry. The probability of this occurring through natural processes is less than 1%. Industrial alloys, the kind humanity manufactures for spacecraft components. The kind you'd use if building something meant to last 10 billion years. But one anomaly proves nothing. Maybe 3I Atlas formed in an unusual stellar environment. Maybe its ejection process preferentially removed iron. Nature is creative, except there were more anomalies. Water content. Every comet humanity has studied extensively contains water ice as its primary component. The famous dirty snowball model. Water dominates at 70 to 80% by mass. Interstellar comet Borisov, which passed through in 2019, measured 68%, right in the expected range. 3I Atlas's water content, 4.2%. It was venting water vapor, yes. That's how we classified it as active. But the total water fraction was absurdly low. Lower than any comet in our database. Lower than most asteroids. What kind of comet barely contains water? Dr. Michael DeSanti at NASA Goddard tried to reconcile this. Maybe it was a Manx comet with depleted volatiles. But Manx comets still have 20 to 30% water. Maybe the water was locked deep in the interior. But that didn't match the observed gas production rates. The statistical probability of a comet having this little water while still showing active outgassing, less than 1%. Add it to the running calculation, trajectory precision times nickel ratio times water content. We're down to 1 in 250 million now. Polarization. When light scatters off a surface, it becomes polarized. The degree depends on composition and structure. The Very Large Telescope conducted polarimetric observations, August 19, 2024. The results made no sense. Negative polarization, strongly negative, measured at 2.8% at a 37-degree phase angle. Every comet we've measured shows positive polarization in this geometry. Typical range is +1 to +2%. Borisov measured +1.1%. Negative polarization implies highly organized surface structure, crystalline materials, or metallic surfaces with specific geometric properties. The VLT team's conclusion: the observed polarization state has no precedent in cometary observations and suggests surface properties unlike any previously characterized solar system object. Probability of this occurring naturally, less than 0.5%. Multiply it in 1 in 500 million. Each individual anomaly could have a natural explanation, unlikely requiring special circumstances, but not impossible. But when you stack anomalies, when every independent measurement reveals something statistically improbable, coincidence breaks down. This is how detectives solve crimes. No single piece proves guilt, but cumulative weight becomes overwhelming. Stack enough pieces and the probability of innocence becomes vanishingly small. On October 28, 2025, Dr. Zhang and Dr. Datum published their analysis of the blue light phenomenon. They showed definitively that solar heating couldn't explain the observations. The comet's surface at perihelion shouldn't have exceeded 400 Kelvin, nowhere near hot enough to produce blue emission. Blue light means high temperature. For 3I Atlas to glow blue, some portion needed to reach at least 6,000 Kelvin. That's hotter than the sun's photosphere. There are exactly 3 ways to generate that heat. Radioactive decay doesn't last 10 billion years. Chemical reactions can't sustain those temperatures. That leaves nuclear fusion or exotic high-energy processes. Technology. Dr. Blackwood's team finished their backward trajectory reconstruction November 2nd. Dr. Werner's forward prediction analysis finished November 3rd. On November 4th, they shared results. The agreement was unsettling. Both teams had independently determined that 3I Atlas's initial entry conditions required absurd precision. Entry angle, correct to 0.001 degrees. Entry velocity, correct to 0.1 meters per second. Entry timing, correct within 2 hours. Those aren't natural parameters. Those are targeting solutions. When you fire a missile thousands of kilometers or send a spacecraft to Mars, you calculate with that precision. When you're hitting a specific point at a specific time, you need those constraints. Natural objects don't aim. They drift wherever gravity takes them. Unless they're not natural. November 5th, Dr. Blackwood ran one final simulation. She forced her model to match every observed constraint. The simulation spat back a solution requiring adjustments. Small velocity changes applied at specific times. Exactly matching the 3 episodes of perpendicular thrust ESA had detected. July 28th to August 3rd. Delta V of 0.518 km/s. September 25th to 28th. 0.48 km/s. October 23rd to 26th. 0.46 km/s. Those weren't random outgassing bursts. Those were course corrections, calculated, deliberate, executed with precision. And here's what made Dr. Blackwood stop sleeping. When she calculated backward to determine where 3I Atlas originated 10 billion years ago, she got a direction. Ursa Major. Approximately 9 degrees from a very specific point. The same point where the WOW signal originated. In 1977, Big Ear Radio Telescope detected a powerful narrowband signal lasting 72 seconds. So strong, so clearly non-natural that astronomer Jerry Eman wrote, "Wow," in the margin. The signal came from Sagittarius, near the Ursa Major border. 3I Atlas's origin point, 9 degrees away. Angular separation too close to ignore. What are the odds an anomalous interstellar object arrives from the same direction as the most famous potential alien signal? Dr. Blackwood estimated conservatively, 0.6%. Multiply that into cumulative probability. Trajectory times alignment times, composition times, polarization times, WOW signal direction. 1 in 94 sextillion. Dr. Blackwood called Dr. Werner. "Tell me your numbers are wrong." I was about to ask you the same thing. They weren't wrong. 3 independent verification checks confirmed it. The math was solid. The data was solid. The conclusion inescapable. Something had aimed 3I Atlas at our solar system. Something had made course corrections. Something had maintained operational capability for 10 billion years. Dr. Avi Loeb believed it. November 6th, he published preliminary analysis. The perpendicular acceleration vector is inconsistent with known cometary outgassing physics. The cumulative probability of all observed anomalies occurring naturally is below 1 in 10 bar 23. The artificial hypothesis merits serious scientific investigation. The response was swift. Dr. Michelle Bannister called it extraordinary interpretation of ordinary data. Dr. Paul Chodas from NASA issued a statement. While 3I Atlas exhibits unusual characteristics, there is currently no observational evidence that requires non-natural explanations. But behind closed doors, the conversation was different. NASA's Planetary Defense Office scheduled an emergency teleconference. The International Asteroid Warning Network activated observation campaigns early. Radio telescopes received requests to monitor for electromagnetic emissions. Someone was taking this seriously, and someone was sitting on classified data that might answer the question definitively. The Mars Reconnaissance Orbiter images remained unreleased. What did those images show? At 150-meter resolution from 30 million kilometers, MRO couldn't capture fine details, but it could see large-scale structure. If the surface had geometric patterns, regular formations, anything obviously non-random, the images would show it. NASA was sitting on them. The facts suggested one of two things. Either they showed nothing unusual and the delay was routine bureaucratic caution, or they showed something requiring very careful consideration before public release. Which brings us to the question everyone was asking. If 3i Atlas is artificial, what is it? Act 4. The implications. Let's do the math on what it takes to build something like 3i Atlas. Based on brightness and albedo estimates, the nucleus is 5 to 7 kilometers in diameter. Call it 6 kilometers. Volume, roughly 113 cubic kilometers. Typical comet density, 500 kilograms per cubic meter. Multiply and we get approximately 56 billion kilograms. The International Space Station, the largest structure humans have assembled in space, has a mass of 420,000 kilograms. 3i Atlas is 193,000 times more massive. Saturn V, the most powerful rocket ever successfully operated, could lift 140,000 kilograms to low Earth orbit. To launch the equivalent mass of 3i Atlas would require 400,000 Saturn V launches. One per day would take 1,096 years. Now add the requirement this object must survive for 10 billion years. Everything degrades. Cosmic rays damage molecular structures. Micrometeorite impacts erode surfaces. Radiation breaks chemical bonds. Gravitational encounters stress materials. Stars explode. Black holes tear through space-time. Galactic shockwaves ripple through the interstellar medium. To survive, all that requires engineering beyond anything we can imagine. Self-repair mechanisms, redundant systems, radiation shielding that doesn't degrade, structural materials withstanding billions of years of abuse. Voyager 1, launched 1977, is still transmitting but dying. Power depleting. Instruments shutting down. In another decade, maybe two, it goes silent after just 80 years. 3i Atlas has been operational for 200 million times longer. That implies technology so advanced that comparison becomes meaningless. Not 50 years ahead or 100. Potentially billions of years of development. We've had sustained technological development maybe 300 years since the Industrial Revolution. We went from steam engines to quantum computers, horse-drawn carriages to spacecraft, semaphore to global quantum encrypted networks. Extrapolate that forward a billion years. Incomprehensible. Technologies would appear as magic. Not metaphorical, sufficiently advanced technology, but actual fundamental incomprehension. We wouldn't have conceptual frameworks to understand what we were looking at. But let's try. Let's speculate about what 3i Atlas might be. Hypothesis 1. Autonomous probe. Self-directed exploratory mission launched by a civilization that may no longer exist. Purpose, survey the galaxy, catalog stellar systems, identify habitable worlds, search for life. Mission profile is simple. Enter a solar system on high-speed trajectory. Use stellar gravity for minor adjustments. Pass through the habitable zone. Scan for biosignatures, technological signatures, anything interesting. Record data, continue to next system. Over 10 billion years, a single probe could visit millions of stars. If launched with sufficient velocity, equipped with gravitational slingshot capabilities, it could cross the galaxy multiple times. The builders might be extinct. Their star died billions of years ago. Their planet a cold cinder or scattered asteroid rubble. But their probe continues, still following programming, still executing its mission. A ghost ship from a dead civilization. There's something profoundly lonely about that. This ancient machine, older than our world, carrying knowledge of species we'll never meet. Recording our existence for an audience that will never see the report, unless they still exist. Hypothesis 2. The builders are still out there, still active, still receiving data from billions of probes scattered throughout the galaxy. 3i Atlas isn't alone. It's one node in a vast listening network mapping the Milky Way for eons. If you're Kardashev Type 2 and it's harnessing your star's entire energy output, you could build self-replicating probes. Von Neumann machines. Each probe mines asteroids, harvests materials, constructs copies. Launch a Dubai Aushart 1,000 seed probes. They travel to nearby systems. Each builds 10 copies. Now you have 10,000. They spread. Each builds 10 more. Within a few million years, exponential growth fills the entire galaxy. Conservative estimate. Probes traveling at 10% light speed, spending 1,000 years per system building copies, could saturate all 400 billion star systems in about 10 million years. That's nothing on galactic timescales. A rounding error. A blink. If even one civilization developed self-replicating probe technology successfully, the galaxy should be thick with ancient machines. Thousands could be passing through our solar system. We just couldn't detect them until recently because they're dark, cold, small, but we're detecting them now. Oumuamua 2017, Borisov 2019, 3i Atlas 2024, 3 in 8 years. Is that expected detection rate if the galaxy is filled with probes? We don't know. We have no baseline, no comparison data. We're making first contact with interstellar objects trying to figure out if they're natural or artificial based on limited observations. But here's what we know. If 3i Atlas is artificial, if it's part of a probe network, then the Fermi paradox isn't really a paradox. Whereas everybody becomes, they're here, they've always been here, we just started noticing. The galaxy isn't empty, it's populated. Not necessarily with living beings, but with their emissaries. Machine archaeologists cataloging worlds and species and civilizations as they rise and fall. We might be surrounded by watchers, silent observers maintaining a database of galactic life. Maybe they don't contact us because we haven't reached the threshold yet. We haven't demonstrated technological maturity or longevity worth direct communication. Or maybe they already contacted us and we missed it. Maybe the wow signal was intentional. Maybe it was 3i Atlas pinging us as it approached, sending a greeting, waiting for a response we never sent because we didn't recognize it. 72 seconds, 1 minute, 12 seconds of powerful narrowband transmission at 1420 MHz, the universal frequency of neutral hydrogen. The most obvious frequency any technological civilization would monitor. We heard it, recorded it, wrote wow on the printout, and did nothing. Concluded it must have been interference. Satellite glint, something terrestrial. But what if it was real? What if something broadcast a signal in 1977 trying to establish contact and we failed to respond? Now 48 years later, it's back. Different object or maybe the same network executing a different trajectory. Passing through again. Checking on us. Seeing if we've advanced far enough to recognize what we're looking at. Have we? The scientific community is divided. Most astronomers believe 3i Atlas is natural. Unusual, improbable, but not impossible. Nature is creative. The universe contains phenomena we haven't imagined. A smaller group led by Dr. Loeb and growing numbers of younger researchers argues the artificial hypothesis deserves serious investigation. Not acceptance, investigation. Rigorous, skeptical, peer-reviewed investigation using every tool we have. The difference is subtle but important. Skeptics say prove it's artificial before we consider it. Investigators say treat it as genuine possibility and apply the scientific method. Because extraordinary claims requiring extraordinary evidence cuts both ways. If you claim it's artificial, you need extraordinary evidence. But if you claim it's natural despite exhibiting characteristics seen in 0 other natural objects, you also need extraordinary evidence explaining why. You can't just say unknown natural processes. That's not explanation. That's appeal to ignorance. So let's explore the natural hypothesis properly. What combination of ordinary physics could produce everything observed? Start with age. 10 billion years is genuinely possible. Universe is 13.8 billion years old. First-generation stars formed within a few 100 million years. Those stars lived, died, scattered heavy elements through supernova. Second-generation stars and planets formed by the time the universe was 2 to 3 billion years old. A planet could have formed around an early star 10 billion years ago. Standard physics. That planet gets disrupted. Maybe its star goes supernova. Maybe rogue stellar encounter tears the system apart. Maybe the planet migrates too close and gets tidally shredded. Any mechanism could fragment a world and eject pieces at high velocity. 3i Atlas could be one such fragment. A chunk of ancient planetary core or mantle blasted into interstellar space. That explains age. Explains structural integrity. Solid rock and metal, not fluffy ice. Explains low water content. Planetary cores are dry. Even explains nickel emission. Core material has different composition. Trajectory precision, maybe we're overestimating it. Maybe measurements have smaller error bars than we think. Maybe uncertainties make those trailing digits meaningless. Dr. Bannister made this argument. Modern telescopes are incredibly precise, creating false confidence. Planetary alignment timing? Coincidence. Pure statistical luck. We've detected 3 interstellar objects. Tiny sample size? Maybe 1 in 3 shows weird alignment features. Perpendicular non-gravitational acceleration? Asymmetric outgassing. Weirdly positioned jet venting perpendicular to Sun-comet line. Can't see it directly because gas density is too low. Happens to turn on and off at convenient times because internal pressure cycles match by chance. Blue light emission, radioactive decay. Planetary fragment contains unusually high concentrations of long-lived isotopes. Thorium-232 has 14 billion year half-life. Uranium-238 has 4.5 billion year half-life. Ancient core could still have measurable quantities. Decay produces heat-driving exotic chemistry producing blue emission. See? You can construct natural explanation. Requires special pleading. Requires multiple low-probability events simultaneously. But each individual component is barely plausible. Which is more likely? Natural object with 10 separate unlikely features or one artificial object? Bayesian probability helps. Start with prior assumptions. Before examining evidence, what's your baseline probability an interstellar object is artificial? Conservative estimate, vanishingly small, maybe 1 in a billion. We've never confirmed artificial objects from other civilizations. 0 examples. But now update based on evidence. Every anomaly shifts probability. Stack them all, and posterior probability increases dramatically. Dr. Werner ran the Bayesian calculation. Even starting with 1 in a billion prior, when you update with cumulative evidence, posterior probability becomes 99%. The math says 3i Atlas is artificial. Not with absolute certainty. Nothing in science has that. But with confidence levels far exceeding what we normally require. We accept the Higgs boson on 5 sigma confidence. 1 in 3.5 million chance of statistical fluke. Confidence level for 3i Atlas being artificial exceeds 10 sigma. But statistics aren't physical evidence. Numbers don't prove reality. We need observational confirmation. The smoking gun. Which brings us back to the Mars Reconnaissance Orbiter images. October 2nd, 2024, MRO had 12 to 15 observation windows at 30.2 million kilometers. High-rise resolution, approximately 150 meters per pixel. Enough to see large-scale structure. If the surface had geometric patterns, regular formations, anything obviously non-random, it would be visible. NASA has those images. They've had them over a year. Congresswoman Luna has been asking for release since November 1st. Multiple FOIA requests filed. Standard response. Under review. Classification pending. Why? What requires a year of review? One possibility, nothing. They show boring, irregular rock, natural features, random cratering. NASA is being cautious. Bureaucracy moves slowly. Other possibility, they show something. Something that doesn't look natural. Something geometric requiring very careful thought about public presentation without causing panic. Because that's the real issue, not just science. It's about announcing to 8 billion people that we've detected alien technology in our solar system. How do you manage that message? Prevent societal disruption? Maintain scientific credibility while acknowledging something that sounds like science fiction? You move carefully, consult advisors, prepare statements, coordinate internationally, make absolutely certain before saying anything publicly. And meanwhile, you keep observing. Every major telescope on the planet is preparing to observe 3i Atlas during December closest approach. Hubble scheduled November 12th. James Webb booked December 10th, 20th for thermal imaging. VLT, Keck, Gemini, Subaru, all allocated. Time. Radio observatories are listening. Very large array. Refurbished Arecibo. SETI Institute's Allen Telescope Array. Scanning 110 gigahertz for any signal, any pattern, any transmission that doesn't match natural radio emission. So far, silence. Normal radio noise from comet solar wind interaction. No coherent signals. But December hasn't happened yet. December 19th, 2025, 3i Atlas will be 269 million kilometers from Earth. Our closest look. Best chance. Our moment to answer definitively. In 6 weeks we'll know. Or at least we'll know what the data shows. Whether anyone believes it, whether institutions acknowledge it, that's different. The clock is ticking. Every hour, 3i Atlas travels 87,000 kilometers farther from the Sun. Every day, colder, darker, more distant. By December's end, it crosses beyond Mars's orbit, beginning the long journey back to interstellar space. This is our window. Our chance. Our opportunity to solve one of humanity's greatest mysteries. Are we alone? Right now, somewhere in the darkness, an object 10 billion years old moves through our solar system. An object defying every natural explanation. An object whose existence suggests intelligence beyond comprehension. The math points to design. The evidence points to technology. The probability points to something we've wondered about since the first human looked up and asked that fundamental question. In 6 weeks, we might finally have an answer. Or we might watch our best chance slip away into the void, leaving nothing but anomalies and questions and the lingering suspicion that something extraordinary visited us and we failed to recognize it. The universe is about to tell us a secret, whether we're ready to hear it or not. Act 5, The Resolution. November 7th, 2025. Early morning. The astronomy world is quietly fracturing along a fault line that's been building for months. Not the dramatic public split you might expect, not heated debates on cable news or viral social media wars. This is happening in conference rooms and private emails and late-night phone calls between colleagues who've known each other for decades. The question isn't whether 3i Atlas is unusual. Everyone agrees on that. The question is what unusual means. Whether it crosses the threshold from really weird natural object into territory that requires a fundamental reassessment of our cosmic assumptions. NASA's official position, released November 4th in a carefully worded statement, walks a diplomatic tightrope. 3i Atlas exhibits unusual characteristics consistent with an ancient, compositionally atypical interstellar object. While certain properties remain unexplained within current models, ongoing analysis has not identified definitive evidence supporting non-natural origins. We continue to gather observational data and welcome peer review of all findings. Read between the lines and you see the hedging. Not identified definitive evidence isn't the same as ruled out. Artificial origin. It's leaving the door open while maintaining plausible deniability. Standard institutional behavior when facing a conclusion too extraordinary to embrace without absolute proof. Dr. Klaus Werner at the European Space Agency has been slightly more direct. In an interview with Nature published November 6th, he said something that's being quoted extensively across astronomical circles. The trajectory precision is remarkable and merits further investigation. Multiple natural mechanisms could potentially explain individual observed phenomena. However, the cumulative statistical weight deserves serious consideration. We are committed to full data transparency and will release our complete analysis November 20th. That phrase, cumulative statistical weight, is doing a lot of work. It's as close as a mainstream institutional scientist can come to saying, this might actually be artificial without committing career suicide. The SETI Institute mobilized quickly. Dr. Jill Tarter, who spent decades searching for radio signals from distant civilizations only to find silence, is now pointing every available instrument at an object inside our own solar system. We're conducting comprehensive radio frequency monitoring from November 7th through December 31st, she announced at a hastily organized press briefing. Scanning 1 to 10 gigahertz with particular attention to the 1420 megahertz hydrogen line. If 3i Atlas is transmitting, we'll detect it. So far, nothing. 8 hours into the monitoring campaign, the radio telescopes are picking up exactly what you'd expect from a comet. Natural broadband emissions from the interaction between outgassing and the solar wind. Plasma waves, magnetic field fluctuations. Nothing coherent, nothing organized. No patterns that rise above statistical noise. But absence of detection doesn't mean absence of signal. Maybe it's transmitting on frequencies we're not monitoring. Maybe it uses directional beams aimed elsewhere. Maybe it operates in receive-only mode, passively collecting data. Or maybe most likely it's just a really weird comet and there's nothing to detect. Dr. Avi Loeb remains the most vocal proponent of serious investigation. His preliminary paper, uploaded to the Archive preprint server November 5th, makes the statistical argument explicit. Statistical analysis of 3i Atlas anomalies, natural or technological origin, runs through every calculation, every probability estimate, every piece of evidence. His conclusion pulls no punches. The probability of natural origin, given the observed characteristics, is less than 10^23. While this does not constitute proof of artificial origin, it establishes a threshold warranting dedicated observational resources and serious scientific inquiry free from stigma or career concerns. That last phrase, free from stigma or career concerns, recognizes the elephant in the room. Suggesting an interstellar object might be technological remains. Borderline taboo in mainstream astronomy. It's the kind of claim that gets you labeled a crank, lumped in with UFO enthusiasts and ancient alien theorists. Scientists early in their careers avoid it entirely. Even established researchers approach the topic with extreme caution, burying the speculation in layers of careful hedging. But the data doesn't care about career concerns. The math doesn't care about stigma. And a small but growing number of astronomers are willing to say publicly what many are thinking privately. This deserves investigation commensurate with the stakes. Because make no mistake, the stakes are existential. If 3i Atlas is artificial, everything changes. Not gradually, not eventually. Immediately and fundamentally. The Fermi paradox, the question that's haunted humanity since we first understood the scale of the cosmos, gets answered. Where is everybody? They're here. They've been here. The galaxy isn't an empty wasteland punctuated by rare islands of life struggling in isolation. It's populated, mapped, monitored by intelligences that achieved technology when our solar system didn't exist. We're not alone. We never were. We were just too primitive to notice the watchers. That realization would transform human civilization overnight. Every philosophical framework, every religious tradition, every assumption about our place in the universe would require reassessment. Are we important? Are we unique? Are we protected or endangered by the attention of intelligences billions of years more advanced? The implications cascade outward. If probes from ancient civilizations routinely pass through stellar systems, that suggests galactic-scale coordination, infrastructure, communication networks spanning light years or light centuries, technologies that make our most advanced achievements look like stone tools. It suggests that intelligence, once it emerges, can survive indefinitely if it makes the right choices. The Great Filter, the hypothetical barrier that prevents civilizations from reaching galactic prominence, becomes less terrifying. Someone made it through. Someone survived. Which means we might too. Or it suggests something darker. Maybe the probes are all that's left. Maybe civilizations inevitably destroy themselves or fade into extinction, leaving only their autonomous machines to continue the mission. Maybe we're looking at archaeological remnants of a galaxy that was once vibrant with life and is now mostly tombs and ghosts. These aren't idle speculations. These are actual possible implications of what the math is telling us about 3i Atlas. That's why institutions are moving carefully. That's why NASA hasn't released the Mars Reconnaissance Orbiter images. That's why China's Purple Mountain Observatory went silent. Because once you open this door, you can't close it. Once you announce that an interstellar object shows evidence of intelligent design, you can't walk it back. You can't say, never mind, we were wrong, without destroying institutional credibility permanently. So they wait, they gather more data, they run more analyses, they prepare for multiple scenarios, and while they wait, 3i Atlas keeps moving. Right now, this moment, it's approximately 225 million kilometers from Earth, traveling outbound at 87,000 kilometers per hour, getting colder, getting darker, fading from the intense blue glow it exhibited at perihelion back to the dim reflected light of a distant object. In 6 days, November 13th, it crosses Mars's orbital path outbound. In 2 weeks, November 20th, the ESA releases its complete trajectory analysis. In 5 weeks, December 12th, the James Webb Space Telescope begins its thermal mapping campaign. In 6 weeks, December 19th, closest approach to Earth. That December 19th date is circled on calendars in observatories worldwide. It's our best viewing geometry, our optimal chance. Every major telescope has allocated observation time. Amateur astronomers are preparing equipment. Citizen science projects are organizing data collection campaigns. If 3i Atlas is going to reveal its nature, December 19th is when it happens. And if it doesn't, if the close approach shows nothing definitive, we're left with exactly what we have now. Anomalies. Probabilities. Suggestions. No proof. No certainty. Just the nagging suspicion that something extraordinary passed through our solar system and we couldn't quite confirm it. That might be the most frustrating outcome. Not proof of artificial origin, which would be world-changing, but at least definitive. Not proof of natural origin, which would let us relax back into comfortable assumptions. But ambiguity. Eternal uncertainty. The unanswered question hanging over humanity forever. Unless the classified data provides clarity. Unless those Mars Reconnaissance Orbiter images NASA is sitting on show something unambiguous. Unless someone somewhere decides that transparency outweighs caution. Congresswoman Anna Paulina Luna hasn't given up. On November 6th, she submitted formal written questions to NASA Administrator demanding a timeline for MRO data release. The American people deserve to know what our instruments observed. Scientific transparency is not optional. I expect detailed responses within 7 days. Whether that pressure produces results remains to be seen. Meanwhile, ordinary people are paying attention. Google search traffic for 3i Atlas spiked 400% on November 6th after Dr. Loeb's paper started circulating on social media. Mainstream news outlets, which initially ignored the story, are starting to cover it. Not front-page headlines yet, but science sections are running pieces. Mysterious interstellar object raises questions tends to be the framing. Careful, hedged, but present. Public interest will intensify as December approaches. When James Webb images start releasing. When amateur astronomers capture their own observations. When the December 19th closest approach generates inevitable media coverage. At some point, this becomes a story too big to ignore. At some point, institutions will have to make definitive statements instead of hedging. At some point, humanity collectively will have to grapple with the possibility that we've detected evidence of alien technology. Are we ready for that? Probably not. No civilization is ready to have its cosmic assumptions overturned. But ready or not, the data exists. The math exists. The probabilities exist. 1 in 94 sextillion. You can dismiss it as coincidence if you want. You can argue that improbable isn't impossible. You can wait for more evidence, demand higher standards of proof, insist that extraordinary claims require extraordinary evidence, all valid positions, all scientifically defensible. But at some point, you have to acknowledge what the numbers are saying. You have to recognize that stacking coincidences eventually becomes less plausible than accepting the alternative explanation. Maybe that point is now. Maybe it's December. Maybe it's years from now after we've detected dozens more interstellar objects and the pattern becomes undeniable. But the question has been asked, the possibility has been raised, the math has been done. And somewhere out there, moving through the darkness at 87,000 kilometers per hour, an object 10 billion years old continues its journey, indifferent to our debates, unconcerned with our uncertainty, following whatever trajectory it was given by whatever intelligence launched it, for whatever purpose we can barely imagine. In 6 weeks, we get our closest look, our best chance, our moment to answer the oldest question humans have ever asked. Are we alone in the universe? The math says no. The evidence suggests no. The probability calculations point towards something we've dreamed about and feared in equal measure since we first looked up at the stars and wondered. On December 19th, 2025, we might finally know for certain. Or we might watch our best opportunity slip away into the infinite dark, leaving us with nothing but questions and anomalies and the profound, unsettling suspicion that something extraordinary visited our solar system, and we failed to recognize it until too late. The universe is speaking. Whether we're listening carefully enough, whether we're brave enough to hear what it's saying, whether we're ready for the answer, those are different questions entirely. But ready or not, December is coming. The data will arrive, the observations will be made, the analysis will be completed, and then we'll know. One way or another, we'll know. The countdown has begun. 6 weeks until closest approach. 6 weeks until we either confirm the most important discovery in human history or watch the evidence fade back into interstellar space, leaving us exactly where we started, alone with our questions, staring at the stars, wondering.